Hey guys, I want to show you two examples for how to solve a quadratic by factoring when it turns into that type of factoring where the a value in front of the x squared is not 1 and it's also not a greatest common factor. Notice they say solve, so we want to actually figure out what x equals. I'm going to start by subtracting 3 from both sides, which is going to give me 5x squared minus 22x. 11 minus 3 is 8. So I'm going to write plus 8 equals 0. Now I want to show you a little trick. If you go to Desmos and you type in 5x squared minus 22x plus 8, that can give us a clue in our factoring process. So let me just set up a reverse box method. And if I go to Desmos and I type in 5x squared minus 22x plus 8, I can see that this graph has two zeros. And if I click on them, I have one at 0.4, but I also have one at 4, 0. It's this one at 4, 0, the whole number 0, where I can steal a factor. If there's a 0 at positive 4, let's just remember that the factored form is going to have an x minus 4. And that's a big piece of my puzzle, because if I look at this, then I'm thinking negative 4 times something equals positive 8. And we know that something is a negative 2. Negative 2 times negative 4 gives us positive 8. And now I just fill in what's going to multiply with this x. That's going to give me 5x squared, and that's going to be 5x. And just to prove that this works, if I fill in the rest of the box, I'm going to have 5x times negative 4 is negative 20x, and negative 2 times x is negative 2x. And notice that those sum to negative 22x. So I have now put it in factored form. I'm just going to transfer that into my required work. X minus 4 times 5x minus 2 equals 0. And now I'm just going to set each factor equal to 0 and solve each one for x. The first one, I'm just going to add 4 on both sides of the equal sign. These 4's will zero out and give me x equals positive 4. The next equation we have to handle in 2 steps. The first thing you always want to do is add or subtract. So I'm going to add 2 to both sides. I'm going to bring down the 5x, and it equals positive 2. And then this really means 5 times x, so I'm going to divide both sides by 5. And then I get x equals, you could leave it as 2/5, or you could type 2 divided by 5 in your calculator, which is 0.4. Either way. I kind of prefer to leave it as a fraction, but you could write it as a decimal. All right, so that's the first example. I wanted to show you, well, just to recap before we do that. We looked at the graph of 5x squared plus 8. We noticed that it had 2 zeros. It made a parabola. One was at 0.4 comma something. We're only looking at the x's. And the other one was at positive 4, 0. Well, I guess that was 0. And we noticed that since the factor was positive 4, that told us that a factor was x minus 4. So that's kind of what we looked at. Now let's take a look at another example. That 4x squared minus 10 equals 4x minus 7. So I'm going to subtract 4x and add 7. Now notice there's no x term to line it up with, so I just know that I'm going to have a minus 4x, but I can line up the plus 7. Right-hand side's going to zero out. Negative 10 plus 7 is negative 3. Keep in mind that 4x squared and 4x are not like terms, so you cannot combine them. You can just bring them down. And now I have this equation. So let me go ahead and graph that equation, and then we can talk about it. It was 4x squared minus 4x minus 3. 4x squared minus 4x minus 3. Take a look at those zeros. They're at negative 0.5 and 1.5. So let's just kind of make a sketch of that situation. Got a parabola whose zeros are negative 0.5, and I believe it was 1.5. Neither of which are integers. They're not whole numbers. But this is actually giving me a clue. When I try to factor this, let me just set this up. 4x squared minus 4x minus 3. If one of these was an integer, then I would know that I would have just an x plus or minus another number. But I don't have an integer 0. So that's actually a clue that I'm going to break up 4x squared into 2x times 2x. And then I'm just left with looking at this negative 3 and thinking about its factors. Well, the number 3 is a prime number. It only has factors of 1 and 3. If I fill this in, 3 times 2x is 6x, 2x times 1 is 2x, and we think about what can you do with 6x and 2x so that it sums to negative 4x. Well, if I make this 6x a negative, which would make this 3 a negative, then it works. Negative 6 plus 2 is negative 4. And that means I want to keep this 1 a positive 1. So there's my factored form. So I'll just transfer that over here. 2x plus 1 times 2x minus 3 equals 0. And then I'll proceed to set each factor equal to 0 and solve for x. 2x plus 1 equals 0. 2x minus 3 equals 0. And then to solve the first one, I want to subtract 1 from both sides, which gives me 2x equals negative 1. And then divide by 2. We get 1x equals negative 0.5, right? Which matches with what we got in the graph. I'll just leave it as a, you could leave it as a fraction, or you could write it as a decimal. That's your choice. I'll just leave it as a fraction. Okay, so now I'm going to solve the other one in 2 steps. I'm going to add the 3, which will give me 3 on the right-hand side, and negative 3 plus 3 will zero out, and I'll bring down the 2x. Then I'll divide both sides by 2. 2's cancel. I get x equals 3 halves, and if you do 3 divided by 2, you get 1.5, which again matches up with our other 0. So there you go. I'd say these are probably some of the more advanced solving by factoring problems. So hopefully you could follow that, and thank you for watching.